everybody. One of the key ideas in this unit is the idea of momentum conservation. Momentum conservation just means that if we have an object that's moving and therefore has momentum, its momentum will always remain the same so long as there are no outside forces acting on it. I've set up this cart on this track. For the moment, we're going to take this system to be frictionless. The reason this is important is that friction is an outside force on this cart, and so it would break momentum conservation. But for the relatively short time periods we're going to be looking at in this example, thinking of it as being frictionless is just fine. We have two pieces of Velcro on this side of the cart, and at the end of the track, there's two more pieces of Velcro facing the other way. Let's see what happens when we push the cart to the end of the track. Notice that the car stuck to the end of the track. Clearly, the momentum of the cart was not conserved. Initially, it was moving, and now it's no longer moving. This means that there has to be some sort of outside force on the object, but it's up to you to figure out where that force is and what it's doing. Let's look at one more example. This cart has a bumper attached to a spring, meaning that if it hits something, it can bounce off of it and start traveling the other way. Let's try that and see what happens here. As we expected, the cart bounced off the end of the track and started moving back. It ended up moving to the left at roughly the same speed as it was moving to the right. But this does not mean that momentum is conserved. Momentum is related to the mass and velocity of an object, and velocity is a vector. It both has a value and a direction. So the fact that this cart's direction changed means that its momentum changed, even though the speed that it was traveling at was the same in both directions. As before, this means there was an external force on the cart. So where did this force come from? Your first instinct might be to say that it came from the spring. But this is not correct. The spring is part of the cart. You cannot get an external force from the object itself. It has to come from somewhere else. Where did it come from? Well, as with the first case, that's for you to figure out.